welcome to Access Granted Equations, where we explore building accessible digital experiences. I'm Rachel Ruprecht, a senior instructional designer here at Broward College.
And I'm Heidi Keller, also a senior instructional designer at Broward College.
Today we're going to talk through how to make equations accessible, and this can cover all types of equations, whether in engineering, math, chemistry, what have you. So the challenge with equations is that without correct formatting, they cannot be read by assistive technology such as a screen reader. They just simply aren't intelligible. There's a lot of obstacles here to making them intelligible to that assistive technology. The first is that there's often a bigger challenge in retrofitting existing documents than recreating them, but departments and instructors can often have a lot of content built up in existing inaccessible formats that would be a big lift to recreate. The second is that those are often in the form of PDFs, which, as we've previously discussed, need to be formatted correctly for accessibility or are unintelligible to screen readers and other assistive technology. Equations are often also stored in images, which cannot be read by assistive technology either unless they have the appropriate alt text and formatting there. As we've mentioned, these equations have to be correctly formatted. So there are semantic markup languages in which you do that, but that's something that you have to learn how to do. So there can be a bit of a high barrier to entry to figuring out how to do that, although Heidi's going to show us it doesn't have to be as intimidating as it might seem. Another thing that can be an obstacle is that when equations are copied and pasted from an equation editor into a different context, sometimes they can lose their metadata, which was the formatting that makes it possible for a screen reader to interpret them, and hence become inaccessible. Finally, notational ambiguity of what a particular symbol means in a particular context can make it challenging for a screen reader or an assistive technology user to know what is meant by that symbol in that context without having the broader context of what the meaning of that symbol is. But we have some best practices that can help you navigate through these obstacles. The first and most important one is to use equation editors. These semantic markup languages can make this equations intelligible to assistive technology and are the best way to go about doing so, rather than typing things out independently in different contexts or formats, or using the other things we've talked about that can be those obstacles. Equation editors are the best way to go. Graphs, which can often be a big barrier in math accessibility, need to be accompanied by long descriptions or data tables, which explain what's going on in them. And to make them accessible, it's best to simplify design to focus on the important data points and avoid what can be referred to as chart junk. I mentioned alt text on the previous slide. Alt text should really be a last resort. It's often not able to convey everything that needs to be conveyed in an equation or in a graph, but when it is necessary, it should be written out in plain English. So for example, f of x equals the square root of x squared plus y squared, just as I've said it. You write that out in English. And you may, as a pro tip, want to include the LaTeX, which is one of these semantic markup languages, string in the alt text, which could be helpful for advanced users who would prefer to read out the raw code. And then finally, visual formatting. So remember that accessibility also includes users with low vision or cognitive disabilities, and formatting of the math equations or whatever equations you're dealing with in a way that's helpful for them is important as well. So here we're talking about things like font size, ensuring that you're using at least a 12-point font, color contrast, so that you wouldn't be using color as the only way to convey meaning. For example, saying the red numbers are negative won't be accessible to users who are colorblind. So instead, you'd want to add a minus sign or bolding as well. And then finally, spacing. Don't crowd your equations. Make sure you have ample white space to separate distinct parts of a formula, which can help users with dyslexia or dyscalculia. So finally, we want to remind you again, accessibility is not optional. Accessible equations are a compliance requirement. They are a cornerstone of accessible design. And as your key takeaway while you're working with equations is to ask yourself, have I used an equation editor? So now Heidi is going to show us how to do just that.
Thank you, Rachel. So here I am in a D2L course, and here is an HTML file, a web page. We'll go ahead and look at it, and there is an equation that's copied and pasted as an image. So as Rachel mentioned, this is inaccessible. Right now it's just an object without description, which is not good for somebody with a screen reader. And even if you did add a long description, that's not the best practice. So what you would be tempted to do possibly is to just type out the equation using your keyboard, which is fine until you get to characters such as plus or minus. You may do something like that. And really it just doesn't work well, especially with a fraction and then complex terms and things like that. So we can use instead the equation editor tool, which is this summation icon here. There are a few different equation types. The chemistry and graphical equations are the easiest to use. These require a little bit more knowledge of coding. So we'll click on graphical equation, and we can start typing out our equation. And when we come to things like a fraction, we can use the fraction icon. And our numerator, we can start typing that. And then when we come to the plus or minus symbol, we can go ahead and use that symbol. We also need the square root. We also need the exponent. So let's get our e squared term in there. And then we can finish off with minus 4 AC. So we have our numerator complete, and then our denominator is 2A. So we used the symbols we needed. We'll click Insert, and we'll hit Save and Close. And now you have visually, for fully sighted users, the same equation. I see that the square root didn't make it all the way across, but just for the sake of this demonstration. And then for people that need to use screen readers, the equation editor is fully accessible to them. They'll be able to access each of the parts of the equation correctly. So that is how you use an equation editor in D2L.
Thank you, Heidi. I'll mention too that the one that you've seen is just one of the equation editors that we have access to. There are others that you can get through accessibility resources and the BC App Store, which can allow you to do this sort of thing in other documents as well. So thank you for caring. Thank you for investing the time in making equations accessible, and we hope you found this helpful.